All right, so we're going to start with volumes, which is chapter 26. And volumes are very important for jobs and quantities. And surveyors are called on to do these different types of volumes for various types of materials. So an example would be if we wanted to know how much to order for concrete. We definitely want to get a volume for that. And usually the trucks for concrete can hold about 10 cubic yards. So if we're trying to order and we had a length, a width, and a depth, we could solve the volume. Typically they're in cubic yards. Cubic yards for material like earthwork, cubic yards for concrete. So those are things every day that I'm doing volumes for. You actually could have a volume for stone, but typically we order the stone by tons. So I'm just kind of giving you some, like an intro to it. So the most common ones are cubic yards and cubic meters. So there's 27 cubic feet in a cubic yard because you actually have 3 feet in a yard. And if you're looking at 3 times 3 times 3, which is cube, there's 27. So that's where the 27 comes into play. So if they ask for the answer in cubic yards or it's given in cubic yards, you got to divide it by 27. And then there's also what they call acre foot. That's a volume equal to 1 acre, which is 43,560 square feet in an acre, 1 foot deep. So those are a couple of different measurements. And then you might have water flow, which would be cubic feet per second or cubic meters per second. All right, so methods of volume measurement. So there's 3 typical ones that we're going to use in the book. Volume, again, is length, width, depth. So there's cross-section methods. So when we were in class last week, we did volume by averaged in and volume by prismoidal. So both of those are considered the cross-section method. The second one would be a volume, and you're going to do an area, and it's called a bar pit. And what a bar pit is, and I was telling you all that I went out on a job site, and we had to measure down at certain points how much they cut out each month and to determine an area to pay the contractor. So it was done monthly. And of course, bar pits are very, very sticky and wet. So pretty tough to do, but somebody has to do it. And then the third one, so that was like my hazing to DOT when I first started there. They put the new girl out there with boots that were way too big that they tied around the ankles with like yarn to keep them on. And I stayed in them, but I fell and didn't know how to navigate. And then area by contour. So typically now when I'm doing area, I'm doing it by contour. So I'll use like a total station, and I'll get the area and what the natural ground is before at the very beginning, and then at the end of the month I could do that again, and I could subtract the 2 and it would get me an area really quickly. So that's pretty neat now. So typically that's what I use when I'm getting areas. We still have to do some old school area, but typically, and then each month I could go out there, and if I have the months before and then I actually determine where it is the next month, then I could just subtract the 2, and that gives me how much will you pay the contractor. So those are the 3 type of main principal systems we're going to be using for volume. Okay, so the cross-section method, this produces after center lines have been staked. So we'd have the center line of the road stake, and we'd come out there and we would get shots on the ground at each, like at 0, 0 plus 50, 1 50, we would get a shot at the center line, and then we would do right angles, and we might get a shot 10 or 15 feet to the left, all the way out to the right of way, left and right, and then bring those in our notes. So that's typically how we can do that. And we're going to be seeing notes on that. There's notes in your appendix if you wanted to look at it. All right, so here's this example. So this is actually a center line. The center line of the road is here. It starts at station 10, goes to station 13, so it's only 300 feet. But as you can see, if they're building up, this is the natural ground over here, right here. And at this point, they're having to fill it in. So this is higher than the natural ground. So this particular thing would be called a fill section. Right in here, it starts transposing over. You actually might have a fill on one side and a cut on the right. So it's starting to transfer from a cut to a fill. And then when they get here, the road is lower, and it's kind of hard to see with this, and they're having to cut this out. A fill job is going to be a lot more expensive than a cut, because typically you can cut stuff out. If you've got to fill something in, that means you're bringing dirt from off-site. But if you can balance out your cuts and fills and not have to haul so much dirt in, that saves you time and a lot of money. So that's what we're going to be talking about that. So it says it started as a fill, and then from 10 to 11 plus 21, it transitions from a fill to a cut. So it starts doing the transition from 11 plus 21 to 11 plus 64, and then the 11 plus 64 to 13 is all cut. And we'll do a chart. We're going to be doing a chart on that in a little bit. All right, so types of cross sections. So I'm going to scroll down. So types of cross section will be a flat terrain. That's typically the one we're going to be using is a level section. It's suitable if it's level. Then there's a 3-level section. It's generally used when ordinary ground conditions prevail. If it's really, really rough topology, we would use a 5-level section. So I'm going to scroll up and show you what those would be. So the typical ones that we're going to be using for area would be a level section, a 3-level section, and we're going to do ones by coordinates, but right now I'm going to concentrate on level and 3-level. All right, so C would be your cut in the center. That stands for C for center, not cut. C, because it could be a feet. It could be this one would be a cut. This would be a fill, but it's still C for center. B is the base of your road. So if your road's 20 foot wide, and S stands for slope. So that's a pretty easy formula. Now, if we have to use the 3-level section, then we actually have center, cut, base, but now we also have a distance left, a distance right, a height left, and a height right. And the heights would be the F, or if it was a cut, it would be the top number. So this one's 6, that would be our height left, height right would be 5.1, distance right would be 20.1, distance left would be 21. And then if we had a 5-level section, that would be what it would look like, but it would be kind of like a plug and chug with that one. So these are the ones we're mainly going to use. All right, so the next thing would be, and that's just solving for areas. That's not a volume. That's solving for the area of one station. And we could do a combination of two. That's solving area, and then we're going to use the areas to solve for volumes. So the first one is what you would see V sub E. That's volume by averaged in. So in the book, somebody was asking me, V sub E would be area 1 plus area 2, and that would be you already got your end stations, separated by L, and L's a distance. So here's the example right here. Area 1, area 2, and your length. I would recommend using either equation 26-1A or 26-1B. English metric. So it's taken the area, the average the two areas, times your length divided by 27. So 27 is converting our answer to cubic yards. So the length's in feet, so right here it says L's in feet. Now the only difference for volume by average N, so you'll start seeing that V sub E, is that you don't divide by 27 because we're not putting it in yards. So that would be you just take out the 27. This equation 26.2, this can only be used if it's a 100-foot station. So it leaves out an extra calculation for you, but I find some maybe that are working problems accidentally get it mixed up and their distance was only 60 feet and then they tried to use that formula and the answer was wrong. So I would recommend go ahead and always using this formula, because all they did is to get this 1.852, they took the length at 100 feet, divided it by 2 times 27, and that gave them the 1.852. So we're going to start our first problem, and it says compute the volume of the excavation between 24, and here's the area, it's 711 square feet, and station 25 with the averaged in area 515. So I'm going to go ahead and go back and use my equation. I'm going to use the equation 26.1. So it's going to be area 1 plus area 2 over 2 times L divided by 27 cubic yards. So area 1 would be a 711 plus 515 divided by 2, and then I'm going to do 100 divided by 27. And see, and that's cubic feet per cubic yard. That's just feet. That's just, this is square feet. Alright, so ours is going to be a little bit different than theirs because they used the shorter equation to work with it. So 711 plus 515, and we're going to multiply that by 100 divided by 27. So I got 227, 0, and basically if we were using 3 significant figures, that would be your answer right there. I got 2270.37. Alright, so that's pretty simple. Alright, I'm going to work one simple one in the back of the book also, using some of the formulas, because they already gave you the area here, but if we want to go back and work with the area, I'm going to work a problem in the back of the book, which would be, I think we worked this in class. I want to work problem 26.4. So I'm just going to type it in down here real quick. Problem 26.4. That's on page 795. Okay, you're given 2 level sections. They're 75 feet apart. So my L is 75 feet apart. it says that the center cuts, you have one center is 4.8. They're both in a fill. And the other center is 7.2. Your base is 30. And slopes are 2 to 1. Alright, so I'm going to flip up and I'm going to use the 3-level section. So if I'm solving area for the first one, so area equals, my C for the first one is 4.8 times B 30 plus S times C. And my S would be the 2, that's your slope, times C, 4.8. And that'll give me an area in square feet. So that gives me 190.08. Okay, and that's my area 1, and I'm going to do an area 2. And we're switching out, and our C this time is 7.2. 30 plus 2 and 7.2. $319.68. All right, and then so it just asks for the area, draw the cross sections, and compute V sub E. So they want V sub E, so they want volume by prismoidal. So I'm going to scroll up, and they want V sub E. V sub E would be area 1, 190.08 plus 319.68 divided by 2 times your length, and this one's 75 feet, divided by 27. And I got V sub E being 708 cubic yards. Now let me check that. I know we worked this in class. And it's in the back of your book. Yep, 708 cubic yards. All right, so that's a wrap. That's how you can solve volume by prismoidal, volume by averaged N, and actually solving your area by 2-level sections.